Welcome to the session on information and energy efficiency. My name is Pascal da Costa. I'm full professor at CentraleSupélec, Université Paris-Saclay, France, and I will share this session. Today, we will have three presentations on energy savings or conservation, three applied experimental economic papers that assess the impact of monetary information or electronic reports, and last but not least, the effect of nudges on energy saving for households. These are highly relevant subjects for the future of the electricity and energy system, since we all know that electricity consumption will also have to decrease for particular demand sectors and some households, in order to achieve the objective of reduction of greenhouse gases emissions. And we all know that power generation technology alone, that is to say the supply side of the economy, cannot do the job alone. Now, I would like to remind you a few rules so that everyone can present in the best possible conditions. Each presentation should not last more than 22 minutes, about 22 minutes, followed by 8 minutes of questions and discussions. About the questions and comments of the audience, please introduce yourself quickly before asking your question or making your remark and comments. Thank you. So the first paper is entitled "The Effect of Providing Monetary Information on Energy Savings for Household Appliances" by Amaya de Ayala, University of the Basque Country and Basque Center for Climate Change, Spain. Amaya, I give you the floor right now. Thank you.
Thank you very much, Pascal. Thank you for the good introduction to the session. So now I'm going to share my slides. So tell me if it works. Yeah, you can see them. So now I put the full presentation.
That's good. Okay. Yeah, but you're not in full. Yeah, no, you're in full.
Okay, great. So good morning, everyone. It's a pleasure to be here in this session. My name, as Pascal has said, is Amaya de Ayala. I'm currently assistant professor at the University of the Basque Country here in Spain, and also associate researcher at Basque Center for Climate Change. So the work that I'm going to present today is entitled "The Effect of Energy Labeling on Consumers' Purchasing Decision for Appliances." And for this, we carry out a field trial in Spain. Well, let's start with the introduction. So as we all know, the energy efficiency is one of the main instruments for reducing household energy consumption. However, although energy efficiency presents not only economic but also environmental benefits, such as cost reduction, carbon emissions reductions, from an economic point of view, there is an apparent underinvestment in it. And this is called in the literature as the energy efficiency gap or the energy efficiency paradox. In order to cope with this energy efficiency gap or paradox, there are several policy instruments, and one of the most common ones for reducing, in particular, informational failures are the energy efficiency labels. So here, I show you the European energy efficiency label. On the left-hand side, you can see the old label that was available this February 2021. And on the right-hand side, you can see the new one, available from March of this year. So as you can see, the label, what they show us. So on the one hand, they show us the energy efficiency label of the appliance in question. In this particular case, I show you for the case of a washing machine, okay? So in this case, we have a scale from the A to the G. And they show also the energy efficiency consumption in kilowatt hours, and also some technical information such as the water consumption or the noise level. Well, saying that, we know that in order to have effective energy efficiency labels, it is very important that individuals must be aware of it must understand all the information that this label provides, also must trust that information, and all in all, must find all the information useful. So there are two crucial factors in it. One, the type of information they present, so the energy consumption, the emissions reduction, the technical information, and also the way this information is presented in the label. If it is presented in a scale with colors in a horizontal or vertical scale. So under this context, recent research has analyzed if providing monetary information about the energy consumption can be effective in promoting more energy efficient purchases. That is to say, we want to translate this energy consumption information in kilowatt hours into euros, and we want to see if this can affect the decision-making process of the consumers. Well, so having said that, our objective was to test the effectiveness of providing monetary information, and in particular, we provide lifetime energy savings at the point of sales in order to promote the purchase of energy efficient household appliances in Spain, in this case. And how we did that? We conducted a field experiment which allows us to have a real situation with real purchases and real purchases. In total, 26 small retailers took part in Spain in different autonomous communities of Spain. We conducted it between February and July of 2018. So in total, the experiment ran for 6 months. And the appliances we consider were the most common ones in the Spanish households, that are first washing machine, fridge, and the dishwasher. Well, in order to test the effectiveness of providing lifetime energy savings information, we designed three different treatments, and we test the fact of providing monetary information through these sequential treatments. First, the treatment 1, the retailers add a monetary label showing this lifetime energy savings. And this monetary label was placed next to the official one, okay? So it was placed on the appliance, but next to the European one. In the second treatment, retailers removed the previous monetary label, and what we did is to train the sales staff so that the sales staff provide that information about the sales, about the lifetime energy savings. So we removed the label, but the sales staff provided that information. And in the last treatment, the third treatment, we did like a mix, a combination of the previous two. We place again the monetary label of treatment 1 near to the official one on the appliance, plus the sales staff was also providing that information to their customers. And then we have the control group with no intervention in order to compare it. Well, so, and how we calculate this lifetime energy saving for each of the appliance. So here I show you the formula. It was very easy. What we did is we took into account the maximum energy consumption for that product category. Imagine that we are calculating the lifetime energy savings of a washing machine of 8 kilograms. So we took into account the maximum energy consumption for the case of washing machines of 8 kilograms, which was the one that consumes more. Then the SE, we compare it with the energy consumption of our particular product, the one that we were calculating for, okay? So we did the difference. Then the difference was multiplied by the maximum energy price of the previous year, in our case of 2017, and in Spanish was this one. And also we multiply that by the lifetime of the product that we assume in all cases 10 years based on the conversation with the retailers and the literature. For the three cases, for the washing machine, fridges, and dishwashers. Well, so here I show you the monetary label we designed So as you can see, it is in Spanish, but what we are saying is that for this particular case, for this appliance that was a washing machine of 8 kilograms, the lifetime energy savings was almost 212 euros. Okay, and as you can see on the right-hand side, we place this monetary label near to the official one, okay, on the appliance, in this case on the fridge. Well, in this table, I show you the data we collected. We collected data about technical information, such as the date and place, the brand of the appliance, the model of the appliance. Then we also have energy-related information, the energy efficiency level of that particular appliance, the annual energy consumption, and also information on the attributes, such as the capacity, the water consumption in the case of the washing machine or the dishwasher, or for the 3 cases, we took the information on the price, if there were some price discounts. Also, we took some information about socioeconomics, such as gender, age, and zip code. This was because we carried out a short survey at the point of sale to the customers. So we asked them for gender, age, and zip code. And then with the zip code, we could obtain information on the income, but it was income per capita of that municipality, okay? It was not a personal income per capita. Because we were talking with retailers and they told us that with gender and age was enough. So otherwise the customer were a little bit worried. So here I show you information on the number of sales. As you can see, the most sold product was the washing machine, almost more than the half, followed by the fridge, and finally the dishwasher. Okay, this is very important then to take into account for the results discussion. Well, in this figure, I show to you the percentage of appliances sold per energy efficiency level during the experiment, both in the control group and in the treatment group. So in general, we can see that in both groups, for the case of washing machines, as you can see, the blue one, the level that was most common was the 3+A, okay? Almost all of the washing machines sold were 3+A in both groups. For the case of fridges, we can see that there are between 2+A and 1+A. For the case of dishwasher, also the same proportion of 2+A and 1+A are valid, okay? So in order to estimate the probability of buying a high energy efficient appliance, we assume or we use binary response model, which, as you know, the dependent variable takes the value of 1 or 0. So in order to estimate this probability, we assume different independent variables, including the treatments I explained before, the technical attributes we collected, such as the capacity, the water consumption, the price, also some socioeconomic factors, gender, age, and income per capita of the municipality, and then we include some interaction effects. Well, for the case of washing machines, the dependent variable took the value of 1 if the washing machine was 3+A and 0 otherwise, and then we have different independent variables regarding the attributes and so on. For the case of fridges, the dependent variable also takes the value of 1 if the fridge was 3+A. And for the case of dishwashers, the dependent variable takes the value of 1 if the dishwasher bought was 3+A or 2+A. And in all of them, we assume different independent variables with the treatment, attributes, socioeconomics, and interaction effects. Well, we estimate different model specifications with different independent variables, but finally we choose the ones that provide the best fit. Well, here I show you the marginal effects for the case of washing machines. Well, now we are going to analyze the results. As you can see, regarding the treatments, what we can see is that only in the case of washing machines, only treatment 1, which remember that was to place the monetary label near to the official one, seems to be effective. And then when this one is combined with the sales staff explanations, it's not any more effective. Why? Because one possible explanation is that at the end of the experiment, the sales staff may have the so-called mental fatigue, because remember that the experiment ran for 6 months. But in the particular case of washing machines, as most of them were already 3+A, the sales staff may have little incentive to encourage people to buy 3+A washing machines. That are the possible explanations. Regarding the attributes, as we can see, the capacity and the fact that it is the free installation washing machine has a positive impact on the probability of buying a high energy efficient washing machine, and water consumption, however, a negative impact, which means the higher the water consumption, the lower the probability of buying a high energy efficient washing machine. Well, regarding the interaction effects, we can see that when treatment 1 is applied, price has a negative effect, although it is very small, as you can see. And for the case of income, we can see that when treatment 3 is applied, income has a positive effect on the probability of buying a high energy efficient appliance. Well, here I show you the results for the case of the fridge. So regarding the treatments, in this case, we can see that on the one hand, treatment 2, remember that treatment 2 we remove the monetary label and just the sales staff provide the monetary information. So treatment 2 was effective, and also treatment 3. Remember that treatment 3 was the combination of the previous 2. We have the monetary label plus the explanations of the sales staff. Both of the treatments seems to be effective. However, if we compare the magnitude, we can see that treatment 3 is seems to be less effective. And again, one possible explanation is because, again, as treatment 3 took place at the end of the experiment, sales staff may have the so-called mental fatigue. Then regarding the attributes in the case for fridges, again, the capacity seems to have a positive impact. And in this case, the price has also a positive impact on that probability, because at the end, this is related to the fact that the most energy efficient appliances are usually the most expensive one. And this is in line with our statistics. As you can see, the 3+A fridge is the price of the 3+A fridge is higher than the price of the 2+A fridge. And regarding some other significant effects, we can see that people aged between 30 and 45 years old seems to invest less in energy efficiency. And one possible explanation that we contrast with the literature is because this age, in this range of age, they may are in that childbearing age, and therefore they have less income available to spend in the most expensive and energy efficient fridges. And finally, I show you the dishwashers results. So as you can see, and surprisingly, we didn't find any significant effect for any of the treatments we consider. So the one possible explanation, and in the case of Spain at least, is that because the dishwasher appliance is not the primary appliance in the Spanish household, is not considered as necessary appliance. In fact, this is reflected also by the number of dishwashers purchased in the experiment that, as you remember, was the lowest one compared to the washing machine and fridge. Just almost 17% of the purchases were for the dishwashers. Regarding the attributes, as you can see, the width and the number of services have a positive impact on the probability of buying a 3+A or 2+A dishwasher. And again, water consumption has a negative impact, as in the case of washing machines. So the higher the water consumption, the lower the probability. Price, again, when treatment 3 is applied, has a positive impact. And again, this is related to the fact that the higher efficiency dishwashers are usually the most expensive one. And as you can see, this is in line with our statistics because they present a higher price. And then another significant effect that we found for this particular case is that people aged over 60 years old tend to invest less in energy efficiency because they are not certain about when they are going to recover that investment. So now we come to conclusions. And so what we can say is that providing lifetime energy savings information can be effective in promoting high energy efficiency appliances, but just for the case of washing machines and fridges in Spain, of course. For the case of washing machines, the monetary label seems to be effective. Remember the monetary label showing the lifetime energy savings near to the official one. And for the case of fridges, both the information of the sales staff and also the combination of both, the monetary label plus the information from the sales staff, seem to be effective. At the end, we see that in the case of fridges, providing this information is more effective because what we said is that the consumption of the fridge does not depend as much on the use as could depend for in the case of washing machines or dishwasher. At the end, fridges are connected 24/7, so maybe the energy efficiency plays a bigger role in this case. However, for the case of dishwasher, no one of the treatments seem to have been effective, again, because this is not a primary or necessary appliance in the Spanish households. So what we conclude is that monetary information could be useful, but just for particular appliances. So one possible recommendation, policy recommendation, is that different monetary labels could be proposed, could be designed for its appliance type, take into account different things. So taking into account the characteristics, the peculiarities of each product category. So the consumer preference, the habits, the use, if it is necessary appliance, if it is not, it depends a lot on the use or not. Also, of course, the socioeconomic profile of the consumers, and related to this, the country of implementation. This is very important. And also the type of monetary information we provide. In this particular case, we provide in terms of savings that information, but other studies have provided in terms of cost or emissions reduction and so on. And that's all. Thank you very much for your attention. I will be happy to answer any comment or question. Thanks.
Thank you, Amaya. So, thank you very much. If there are any questions, comments, discussions, please. Yes, Alessandra? Can you just introduce yourself quickly?
Yes, this is Alessandra Motz from the Università della Svizzera Italiana in Lugano. Thanks for this very interesting presentation. I'm not into energy efficiency, but I'm working on consumer behaviors, so I find it really interesting. I was wondering whether it could be an option to model also the choice of like A++ or A+ appliances, because maybe someone couldn't afford the best dishwasher or fridge, but maybe some like the following level could be an improvement with respect to the current situation in any case. So if you have this information, I don't know, could this be interesting or? Yeah.
Yeah, thank you very much, Alessandra, for your comment. In fact, this is a thing that we took into account, okay, that it's not the same. In the case, as you can see, in the case for washing machine, most already were 3+A. So as most of the purchases were 3+A, so we could not see like a real jump because most of them were 3+A. So that's why we assume for the case of washing machines that the probability of buying 3+A washing machine. For the other two, also, there was like a same proportion of the 3+A and 2+A appliances. But so we talked a lot with the retailers, we had a lot of conversation with them, and they told us that most of the purchases were the difference, or the customer were always in doubt between the 2+A and the 3+A. So most of the appliances are in these two categories, the most ones. So that's why we assume to have this jump from the 2+A to the 3+A, because they told us that most of the purchases are in these two categories. So
thank you.
Any questions, please?
Yeah, then I would maybe go ahead. So thank you, Amaya, for your presentation. Really interesting. I was wondering a little bit about the monetary label and this sales staff treatment. So how much they are comparable. So for the monetary label, yeah, you find some significant effect for the washing machines, but then for the other cases you don't. And there you always, so for example, for the fridges, right, it's always the sales staff. And I was just wondering whether, so yeah, you say your policy recommendations also, it depends maybe on the appliance and so on, but with this label, so from the picture as I saw it, your label also looked quite different, or it still had the bars, but it looked different than the official EU energy label. So did you think about the fact that maybe it didn't look as official or something like that? And then that's why maybe the sales, the sales stuff, then that had a higher effect because people listened to that and thought like, okay, now this is the recommendation, but the label is not so, didn't seem so official maybe? Was that something?
Yeah, totally agree with you, Kathrin, totally agree. And this is a fact that we also consider it, because at the end, the label we design it is not official when it does not come from the European Commission, so it's not the same. So the sales staff could not say that this was part of a field experiment in order to don't bias the purchases. So they could not say anything about that they were taking part in an experiment, so they could not say anything. So imagine that people saw in the retailers this label, but they could not know where does it come from, what this label, who does it, because they couldn't say anything, okay, in order to don't affect their purchases. So that's why the information the sales staff provide in the treatment 2 and treatment 3 was very important. So that's why we thought, as you have said, that the treatment 3 has the treatment 2 and treatment 3 in the case of fridges particularly were the most significant one, because at the end they were complemented by the sales staff information. So our recommendation goes in line that this monetary information should be provided with the official European label. So apart from this European label, so also the European Commission can design this kind of extra information or additional information in order to be official and in order to people trust that information. But what we have seen is that providing this kind of information in a way through sales staff or through this extra monetary label, it works and people understand better, and which means that if they understand better, this could affect their purchases. Because at the end, when we ask people if they understand the energy consumption in kilowatt hours, they couldn't understand. They don't know how much is a kilowatt hour, if it is a lot, if it consumes more. But if we say, okay, you are going to save this if you buy this particular appliance, then they can compare, okay, with this I save this, and with this the other. So I think that in their purchasing decision can have an effect. So, and if we want to promote the energy efficiency, I think that we should pay attention to this and put it in a way that normal people could understand it. So that was our recommendation. The way it will be the ideal is the combination, sales staff, to have trained sales staff and to have an official monetary label. Thank you very much.
Okay, thank you. There is a question in the chat of Larissa. I'm reading it. Could you again explain how to interpret the negative coefficients for the interaction between price and treatment for the washing machines and fridge?
Okay. So, vale, que negative coefficient, vale, okay. Yes. In the case of this, okay, I'm reading it. The price presented a negative estimate in the case of interaction effects, because it seems that when treatment 1, if I remember well, is applied, which means is that the price, when this particular treatment is applied, the price has a negative impact, which means that, but I remember that it was very, very, very small, almost zero. So that's why we didn't give a lot of importance to this interpretation, okay? Because it is a little bit counterintuitive, okay? Because it says that the higher is the price, the lower the probability of buying a high energy efficient appliance. And for the other two, I have said the contrary, that the higher the price, the probability of buying a high energy appliance is higher, because it usually goes in line. The most expensive appliances are the ones that present a higher energy efficiency level. But in this particular case, it's the contrary, it's the opposite, but we didn't give a lot of importance because it was significant, but almost it was very small. Econometrics, you know, sometimes.
Thank you, Amaya.
Thank you.
Very clear answer. Is there any question? Maybe one question, one last question. Yes, Alessandra?
Maybe, I don't know, maybe you said it somewhere, but I didn't get the information. Did you consider also the amount of the saving together with the price? Like when you give the information about like the monetary amount that the buyer could save through the lifetime of the appliance, if the saving is higher, I guess, for example, for a very efficient fridge, this could influence the purchase decision next to the simple presence of a treatment.
Okay, I get your question. So you want to see is the amount of the savings could affect the probability of buying a high energy. So we didn't take it directly, to be honest. So, but we consider that in our model at the end we are capturing it, no? Because we are saying, so the probability of buying a high energy efficient appliance depends of presenting this energy savings information, and inside this energy efficiency information there are different levels of savings. So what we are saying is that when we present this energy efficiency information, the probability of buying a high energy efficient appliance is higher, but we cannot say when the savings information is higher, the probability is higher. We cannot say that. What we can say is that the fact that we are providing this affect the probability, but not in the way that you are saying, because we consider probabilistic regressions, and we consider that as a dummy variable. The treatments we consider that with dummy variable, not as quantitative variables.
Yeah, I was asking because I worked with discrete choice models, and so to me it was a bit surprising to have this positive correlation between the probability of choosing an appliance and the price. So I was guessing maybe there is something going on with the amount of saving. So you spend more upfront, but then you save throughout, like, which is also the idea of
that's for sure. That's for sure, because at the end, the most expensive appliances are the ones that are present a higher energy efficiency and therefore higher energy savings. Yeah. So yes, of course, this is related.
Thank you.
Thank you, Alessandra.
Okay, thank you. So the next paper is entitled "Do Electric Home Energy Reports Promote Energy Conservation?" By Kathrin Kaestner of the Leibniz Institute for Economic Research in Germany. So Kathrin, I give you the floor for 22 minutes. Thank you.
Yes, thank you, Pascal. Then I'll also share my screen.
Yes, please.
So now I hope you see it in full screen.
That's perfect.
Perfect. Then, so thank you for the nice introduction, Pascal. I just noticed that I think I didn't follow the rule and forgot to introduce myself when asking my question. So I'll introduce myself now quickly. So yeah, I'm Kathrin. I'm a PhD candidate and a researcher at the RWI, the Leibniz Institute for Economic Research in Essen in Germany. And yeah, I'm really happy to be here today and get the chance to present to you my recent work with my colleagues Mark Andor and Colin Vance. And it has the title, Do Electronic Home Energy Reports Promote Energy Conservation? It Depends. So yeah, as a quick motivation, I mean, we are here in the energy efficiency and information group, so I think we all know that, but, and as also Pascal said earlier in the introduction of the session, energy conservation is an important part to achieve the goal of emission reductions. So on the one hand, we can have cleaner generation with renewable energy sources, and then simultaneously improve energy efficiency and achieve energy savings to reduce the carbon emissions in the energy sector. And the energy sector is an important part that contributes to carbon emissions. And so when we look at it, from the point of the European perspective, so there's this EU directive on energy efficiency even, and that sets a specific target of a final energy consumption reduction by 20% until 2030 compared to 2005 levels. So all European member states, they need to have strategies to achieve these energy reductions. And so when I talk here about these energy conservations, I mean also the electricity sector. So I mean electricity reductions, and especially of private households, because these also usually make up about 1/4 of the final electricity consumption. So there is an important lever that if households decrease their consumption, that this helps to achieve the overall target of electricity consumption reductions. And when we look at it from an economic point of perspective, and also for policymakers to induce these savings for private households, there can be economic incentives, or what we look at here, of course, are the information parts, so the non-price-based instruments. And so, that can be improved information and so-called social norms or social comparisons. And that is an important part of the home energy reports that we're looking at in our study. So if you are not familiar with home energy reports are letters, or can also be emails, but first of all, let's look at letters that are sent to households. And they include usually information about, for example, energy saving tips, but also information about a household's consumption in general. And so they can also be used in the water sector, but here when I talk about home energy reports, I mean home energy reports for the electricity. And then households see how much they consume, for example. And then these home energy reports also include a social comparison part, where households, for example, see how their consumption refers to the average consumption of other households in the zip code, or it is compared to just the consumption of similar households of similar household sizes and so on. And so by this comparison, they are expected to then, if they are, for example, doing worse and have a higher consumption, they're expected to decrease their consumption. And there has already been quite some studies on home energy reports actually, but it's mostly from the US and Australia. And so the most famous ones is probably the ones from the US, from Alcott and Rogers. So they test the effect of these home energy reports sent out by post to households, and they find that they lead to substantial reductions of electricity consumption. So of about 1.4 to 3.3% of the average consumption level. And since electricity consumption in the US is on average 12,000 kilowatt hours per year, these are really substantial reductions. And so then Alcott and Rogers also test the persistence of these letters, and they find that this reduction effect lasts for about 3 months. So if these letters are sent out on a quarterly basis to households, they are a cost-effective measure to reduce electricity consumption of private households. However, in Europe, electricity consumption levels are quite often much lower than in the US. So for example, in Germany, they are about 3,500 kilowatt hours per year. Also in Spain and Austria, they are about 4,000. So Andor et al., they look at the effect of home energy reports in Germany, and they then actually find that they only lead to an average consumption reduction of about 0.7%, so smaller effect sizes. And then given these smaller average consumption levels of electricity in Germany, this is really a very, very small effect and doesn't really lead to a substantial electricity reduction. And therefore, Andor et al. Say that it's not really a cost-effective measure in Germany, only for very high consumption households. There, the effect can be substantial. But therefore, they also conclude that electronic home energy reports, so home energy reports that are sent by email, maybe a more cost-effective measure, because they are even cheaper than sending these letters by post. And so these electronic home energy reports, they have also been studied a little bit, but again, only in the US and Australia with, where, as I said, the average consumption levels are much higher. And there, this effect of these home energy reports sent by email, that's actually a little bit mixed. So for example, Henry et al., they find for the US that the reductions that can be achieved with electronic home energy reports are of the same size as found by Alcott et al. So therefore they say it is a cost-effective measure, the reductions are substantial, and it's even cheaper to send these home energy reports by email than by post. But then Byrne et al. For Australia, they also find reductions in the consumption, but they also find that certain households actually increase their electricity consumption after receiving home energy reports. So there's the so-called boomerang effect, and of course that's not wanted. And they find that for households that overestimate their consumption beforehand. So they first think that they are doing not as good, and then they see in the home energy report that they are doing better than they thought. And so that's why they are found, or that's why they increase then the consumption. Yeah, so there is already some evidence, but these electronic home energy reports haven't been studied for a European country yet, where electricity consumption levels are on average lower than in Australia or the US. And that's where we step in. So we want to test the effect of electronic home energy reports in the European country. So we look at Austria actually and pose the question, do electronic home energy reports in Austria lead to energy savings? And so if we find that there is some substantial reduction, then we could also argue that it's a cost-effective measure because these home energy reports sent by email are quite cheap. And so thus we contribute to the literature by looking at a European country now for electronic home energy reports. And then we have another specialty in our data. Actually, we look at customers of an eco-electricity provider. So our households, they are all customers of this provider in Austria that only has renewable energy sources. So of course, this is quite a special group probably because households that choose an eco-electricity provider may be more environmental friendly and also a little bit more aware of their consumption and maybe also have a higher income. So it is a special group, but we also think that especially this group could be an interesting target group for these home energy reports. Okay, so the data that we use to test the effect of the home energy reports, as I said, is from Austria and eco-electricity customers. And we elicited this data in a large randomized control trial during 2013 and 2016. And back then we had 22,000 customers. Those were all the customers that this eco-electricity provider had back then. And so the share actually has now increased. So I think they have now double as many customers. So this importance of eco-electricity provider is also increasing. But so back then we had these 22,000 households. And in their treatment period, they received then 4 emails, these home energy reports that include energy saving tips and also social comparison part. And I can quickly show you what the social comparison part looks like. So it's in German here, but what it shows is that on the one hand, these households see their annual electricity consumption, and then they see the average consumption of other households in their zip code. And so, for example, here they could already see, okay, mine is 4,800 kilowatt hours. The average is 2,700, so I'm doing worse. And then they also get this evaluation here with smileys, which this would mean very good, good, and satisfactory. So this household, for example, only gets a satisfactory. And so this is also always part of these home energy reports that these households received. Yeah, and they were sent on a roughly quarterly basis between 2015 and 2016. And so we have 2 periods of interest. We have our baseline period and then the treatment period where the mails were sent. And since billing periods for Austrian households may differ in the length a little bit, we look at these more or less annual consumption data and divide them by the number of days in the billing period so that we get average daily consumption levels to make the different households comparable. And then we kick out some extreme outliers and some households where we don't observe any metered data, but only have some extrapolated data. So we're then left with 8,600 observations. And we did a power analysis before the RCT, and there for 80% power, we need 5,000 observations. So we're doing quite good here. Yeah, here you can see one more time the timeline. So we have these meter readings where we see how much the people consumed, and the difference between these meters then gives us the overall consumption in this period, and divided by the number of days, we have then the daily consumption. And so we have the baseline and the treatment where the 4 emails were sent. Our data is well balanced, as you can see here. So for the daily baseline consumption of our households, it's both in the control and the treatment group, about 7.7 kilowatt hours per day. Also the baseline period, the length is about 311 days, so almost 1 year, not quite. And the treatment period is a little bit longer, about 500 days. But so yeah, we account for that by looking at this. Yeah, we look at daily consumption data. So we have this, we account for this. And then also with respect to attrition, we wanted to check whether maybe, so our households were randomized into control and treatment group, right? But we wanted to make sure that there's no systematic attrition. So we checked whether households that terminate their contract during the study, and then the observation of them ends for us, whether this differs in the control or treatment group. But as you can see, it's also very similar. So we don't think that there shouldn't be any systematic attrition. Yeah, since I mentioned now that we have these eco-electricity providers, of course, we also wanted to see how they differ with respect to the general average in Austria. So we compared the annual consumption in kilowatt hours for our estimation sample according to the different federal states in Austria with the Austrian average. And you can see that here down there's the total Austrian average, and you can see that it's on average lower for our sample than for the Austrian households. And that is not so surprising, because these eco-electricity providers, as I said, they may be more environmental friendly and more aware of their consumption. So that's why they might have a lower consumption. Also, they might be smaller households than the average and also have a higher income, so maybe have better appliances at home. So that's why they might have also a lower consumption. And so you can see that, for example, we have a very high share of people living in Vienna, which are also usually of smaller household size, maybe people living in cities. And that is not surprising, because this eco-electricity provider started off in Vienna and then spread out to the other areas in Austria. So that's why we have this high share of people living in the city. One specific thing is also that not all households received all 4 emails in the treatment period. And that was because for some people, the billing period started and ended at different times, but the mails were always sent out at the same time. So then we have some households where the billing period already ended. We don't observe their consumption anymore, and they received the mails afterwards. So therefore we have almost half of them that received all 4 emails, but also quite a few that only received 2 emails or 3. But we take advantage of this by defining different treatment variables to account for the treatment intensity, as you will see in a minute. So now coming to the methods, how do we check the effect of home energy reports? We run a difference in difference estimation, where we have as the dependent variable here the difference of the treatment period consumption and the baseline period consumption. And so by having this difference in difference, we also account for fixed effects that don't vary over time of the households. And we actually normalize this difference also by the post-period control group consumption. That is done also by Alcott, for example. And so first of all, having this difference helps us then that with our treatment dummy T, this coefficient of interest beta already tells us directly the effect as a percentage change. So the average electricity savings as a percentage of the average consumption level. And by having this normalization, we make sure that we can still interpret the effect as this electricity savings as a percentage change without dampening the effect of, for example, large users that have very high consumption levels. And then we also include weak dummies to account for seasonality, and we have them both for the baseline and the treatment period. And then, as I said, we account for the treatment intensity because we have some households that don't receive all 4 emails. So we actually have 3 different treatment dummies. One that is equal to 1 if households receive at least 1 email in the treatment period. And it's 0 if they are assigned to the control group. So we kick out all those households that maybe were assigned to the treatment group but didn't receive any mail, even though those are almost non-existent. But then we have also a treatment dummy that is equal to 1 if households receive at least 3 mails in the treatment period, and then a treatment dummy that is equal to 1 if households receive all 4 emails. Now here you can see our main specifications, where we have here always the different dummies. So at least receiving 1 mail, at least 3 mails, or all 4 emails. And we always run the specification without weak dummies and with weak dummies. With the ones with the weak dummies being our preferred specification, it tends to increase precision. And also the weak dummies, they are important to account for the seasonality. But so overall, you can see now that always looking at these coefficients, they are percentage changes. You would see that it's positive. So that this would mean an increase in the consumption of about 0.1%, so also very small. But you also see that they are not significant. So this one is significant, but as I said, it doesn't include weak dummies. So we want to look more at those with the weak dummies. And we don't find any significant effect of home energy reports on the electricity consumption here. Now we still wanted to test maybe whether there's some heterogeneity. So we looked at the fact whether households, for example, have a higher consumption than the average, because, for example, Andor et al. Find for Germany that these high consumption households, they have a stronger reduction in the electricity consumption. And also households receive the information in the home energy report, right? Whether they are higher than the zip code average or not. So what we do, now this is a big table, but I'll show you what it means. We interact our treatment variables, again, these 3 different ones, with a continuous variable that shows the difference between a household's consumption and the average consumption in the sample. And so the difference, if it's positive, it means that the household's consumption is higher than the average consumption in the sample. And yeah, so I don't show here the constant, but so otherwise it's these are the important coefficients, the ones with the treatment effect alone, and then the interaction with this difference. And as you can see here, nothing is significant, but actually for households that receive at least 3 mails or that receive all 4 mails, we see that the interaction is positive and significant, meaning that households that have a higher consumption than the sample average, they even further increase their electricity consumption. And so, yeah, here, for example, this would be something like 2.8% increase in the consumption, and it's also jointly significant. And so, yeah, that's what we thought is quite interesting. So actually, they don't reduce, but they even increase their consumption. So to conclude, on average, we don't find any significant effect of these home energy reports on the consumption of our customers. But instead, we find that households with an above average consumption even tend to further increase their electricity consumption. So it seems to reinforce their behavior. And this may have several reasons. On the one hand, of course, we have these eco-electricity customers. So maybe they feel that they are already doing more than enough because they are taking electricity from renewable energy sources. And so maybe they're getting, maybe it's a kind of frustration, but yeah, they see that they are actually higher than the others, but then they are kind of thinking, I'm already doing all that I can, so I don't care, I can increase my consumption. That may be one reason. And another one may also be the fact that maybe these households overestimate their consumption, and actually then when they receive the home energy reports, they maybe think, oh, I'm not doing as bad as I thought. But so in general, we think that at least in Austria, for these eco-electricity customers, these electronic home energy reports, given our findings, don't seem to be a suited measure to induce electricity savings. So of course, it's the eco-electricity customers, so maybe they have already, of course, small consumption levels. So even if there's effect, it may be very small, but we even find that some households then don't reduce, but tend to increase even their consumption. So that is not wanted. And so therefore, yeah, maybe it would be interesting to see how it's for non-eco-electricity providers, but in general, for these, it's not an effective measure. Otherwise, I'm at the end. So thank you.
Thank you very much, Kathrin. Thank you for this work, the result of which is very disturbing, since emails proves in Austria to increase maybe electricity consumption. So a very clear presentation for a very complicated problem. Thank you, and thank you very much. Are there any questions, please? Yes, Maximilian, I give you the floor.
Hello, and thank you for this very interesting presentation. I've got one question regarding what's often discussed under moral licensing. So if you found any adverse effects for households that are in fact consuming less than average, and then might be prone to just increase their consumption if they see that they're actually quite good. I mean, if I understood your last point correct, you would not support this behavior, right?
Yeah, exactly. Thank you for the question, Max. It's not moral. We don't find any evidence for this moral licensing. It's more the it's maybe a little bit of a different moral licensing, because now it's not the households that are below that think, oh yeah, I'm allowed to increase, but somehow it's the ones that are above. But then maybe it may be a different kind where they think just because they are these customers of an equal electricity provider, that's the moral licensing, that they think they are legitimated to increase. But otherwise, no, it wouldn't support this very usual definition of the moral licensing.
Thank you.
Then Larissa, you have a question?
Yeah.
Thank you.
Oh, I start my video. So thank you. It's again. Wait. So thank you, Kathrin, for your interesting presentation. I think my question goes in the same direction, namely, do you have any information about how many households got the information that they're doing very good or doing good and doing only satisfactory? Because as you show, the average consumption of your households is much lower than the average of whole Austria. And I could imagine that if a lot of households got the information, okay, you're doing very good, and the average household in your neighborhood or in your zip code is higher, then they think, okay, I can also increase my my electricity consumption. So maybe it's interesting to see how many households actually got which information. So.
Yeah, that's a very good point. So unfortunately, we don't observe that. So it's because it's then anonymous, so we don't know which information they actually received. So that's why we have just this proxy that we take from our sample, the household consumption, compared then to this average consumption that we can calculate from the sample. But it's true that it's an average that is based on equal electricity providers and not on the other Austrian households. But yeah, so that's true. It may be that may be an important explanation actually for that, and maybe would reinforce also the argument that it's not, these home energy reports are then not targeted for the equal electricity providers, because yes, they are always they are on average already lower.
And I think also for households that also have a low electricity consumption, but maybe for households with high electricity consumptions.
Exactly, yeah.
Okay, thank you.
Thank you.
Thank you, Larissa. Other questions? Yes, Alessandra?
Hello, thanks for the interesting presentation. I was wondering, maybe like in line with the previous questions, maybe there is part of the explanation can be that the customers that you consider, they are already they have already reached their margin in a sense, because maybe they are more environmental sensitive, so they have already undertaken efficiency measures. They have also an eco contract, because if I think at my own consumption, okay, Switzerland has, so the retail market is not liberalized, and there is a mandatory, but like unless you opt out, you are automatically put in a fully hydro-based contract if you're a household. So I try to do my best to consume less energy, but there is nothing more that I can do. So maybe this is part of the explanation.
Yes, yes, I agree. So for them, the scope to improve is probably much smaller. Yeah, so it would have been interesting that, I mean, still it could have been the case that those high consumption households, that they still have some more scope. So it's still a little surprising that, yeah, that they then increase it. But I think, yeah, a big explanation is that there is just less scope for them. I mean, that's also what, yeah, Andor I'll find for Germany, that in general, the consumption levels here are lower, for example, than in the US, right? So they're already, it's smaller consumption. So even if there's a reduction, it's quite small, maybe quite small. And so, yeah, so these eco electricity providers, customers, they probably are more environmental friendly and have already done some things. So there's probably less scope, yeah, and that's what this shows, I suppose. Yeah.
Yeah, or maybe there's nothing that they can do over a relatively short time period, like changing the fridge. Maybe you just bought it, so you don't buy it again in 2 years. So yeah, thank you.
Yeah, exactly. Yeah.
Thank you, Alessandra, for the interesting question, and to Kathrin for the answer. Maybe we can take one last question. Amaya, please. Thank you. Your mic is off. Yes.
Sorry. Thank you very much for your interesting presentation. Well, I have 2 questions. One, when they see that the consumption is higher than the average, if I understood well, you also provide some kind of tips, right, to reduce their consumption in this report, right? So
yes, it's independent. Oh, sorry, no. Yeah, ask your question first.
Yes, so then what I conclude is that if they see that they consume more, they receive these tips, but they didn't take into account this kind of tips. These kind of tips were in general or were particular tips? That's the first question. And what I see is that they didn't have effect. And the second question is, maybe it will be, I don't know how it works in Austria, but one thing is to receive the email, and another thing is to receive, to read it, to take into account, and to affect your behavior. So I don't know if you control for that. That I think it's very interesting, because here in Spain, at least, there are a lot of studies that they go in that direction, but that sentence will receive the information, but then the household don't take into account that information. They don't read, they don't pay attention, or whatever. That's it. Thank you.
Yeah, thank you. Very good questions. So with the first one, with the energy saving tips, so they were not particular. So they were not according to whether a household is above or below. They all received the same emails. And so if they saw in their social comparison part, I'm higher, they still received the same energy saving tips as others. Actually, in the 4 mails, the energy saving tips differed a little bit. So it went from different appliances in the household. Yeah, in each mail. So maybe in the first mail, they talked about kitchen appliances, and then in the last mail it was about lighting or something like that. But yeah, so we cannot really disentangle that, because they always had this energy saving tip in the social comparison part. So that's something else. So therefore the focus is a little bit more on the social comparison part. But I would also think that, yeah, they don't seem to pay that much attention, or again, we are here with the problem that they don't have the scope. So even though they see the energy saving tips, they feel like they did already all of this. But we cannot perfectly disentangle that in our analysis. Yeah, but so the energy saving tips were general for everyone. And then with the second part, also very good point. So also in the papers that look at the home energy reports sent by post, they cannot control for the fact whether people really opened these letters. And it's similar with us. We didn't get any link where then people click on that they show us they looked at the email. So we have this problem. So for all, yeah, but I think it's kind of part of all the papers on the home energy reports. We assume that's the treatment. The treatment is that this home energy report was sent to them. So we don't know whether they looked at them. And that's why also it's so interesting to check the effect of electronic home energy reports, because one might argue that they have in general maybe a lower effect because people maybe click less on an email because they just think, oh, it's maybe some spam or something, then open a letter. But so that's interesting that, for example, then in the US, the findings are that it's the same effect as from the post home energy reports. But we cannot control for that. But that can also explain why we don't find any effect. Yeah,
that's super important. There are ways of controlling it so that they can answer to that email saying answering some kind of questions or whatever. There are ways, as I have seen in the literature, so just to let you know.
Yeah, that's true. That's true. We didn't unfortunately do that. So but next time we should.
Okay, thank you very much.
Thank you.
Thank you, Kathrin. A very, very good paper. Thank you very much. So now the last paper of this wonderful session is entitled Nudging Occupants' Behavior Toward Less Energy Consumption in Buildings by Rabab Akkouche from PSL Research University, Center for Applied Mathematics in Sophia Antipolis in France. So Rabab, I give you the floor and you can share your slides. Thank you.
Can you see my slides?
Perfect.
Okay, so hello everybody. I'm so glad to participate in this conference and present our work concerning the impact of using nudges in order to reduce energy consumption in buildings. So I'm Akkouche Rabab. I am a PhD student in MINPI-Tech, and let's start by defining the general context of our study. So as you know, there are a lot of activities that are conducted in buildings and that are responsible of consuming energy. I'm talking about cooling systems, heating systems, appliances, lighting, and hot water. The final energy consumption of tertiary and residential buildings represents 46% of the final energy consumption, and which means it is the most consuming sector of energy. So there are lots of solutions that were introduced in the building sector in order to reduce its energy consumption and to improve its energy efficiency in order to maintain the same comfort for occupants, but at the same time use less energy. There are passive solutions as like raising the performance of the envelope, working on the insulation, on the architecture, on using performance materials, but also some active solutions like technological solutions, monitoring energy consumption, regulation and control, and of course, using efficient equipment and appliances. However, what we can see through lots of studies and in literature, we can see that occupant behavior plays an important role in the different consumption in buildings. So we can take the same type of buildings with the same envelope, with the same architecture, which is localized in the same area, but we can find that we can have different energy consumptions with huge differences depending on the type of occupants we have and depending on their activities. So it's important at the first place to understand this occupant's behavior to be able to model the behavior of occupants in buildings and the change of behavior, and to use some solutions in order to change this behavior and evaluate the impact of this change. In our study, we focus on 3 important elements which will help us quantify the impact of changing occupants' behavior in reducing energy consumption in buildings. So, which is the first one, it is working on experimentation through surveys and data collection. The second part is using dynamic thermal simulation, which is simulation based on some softwares used by engineers in order to predict the way a building responds to some external environmental factors, and which is used to prove the energy performance of a building and achieve certain ratings. So through this dynamic thermal simulation, we can be able to study the impact of the change of behavior and the to have a simulation of the annual consumption of the building. The third element of our work is nudges as a solution from the behavioral economics that I will describe later. So let's just start with the case study of an office building where we are going to show the energy savings we can have through changing occupants' behavior. So the building we studied is an office building located in Nice in France with 3 floors, 1 meeting room, 1 kitchen, and 34 offices. It is a building with 50 occupants. What's interesting about studying this kind of buildings is that, first of all, in an office building, occupants don't pay electricity bill. And through that, we can see the real impact of the solution of nudge we are going to use because there isn't any other financial incentive. And we can really show this impact. The second reason we choose this building is that it is equipped with the smart meters and sensors that will make it easy to conduct the experimentation. So before talking about the energy savings we can have through changing occupants' behavior, it's interesting to just see the impact we can have through just increasing the energy performance of the building through working on its renovation by increasing the performance or raising the performance of the materials used, or adapting the insulation, or the performance of windows, and using efficient equipments for heating, cooling, and lighting. So through these improvements in the building, we can reach up to 19% of energy consumption reduction on the year, and these results we obtained it from dynamic thermal simulation. But what can we have as energy saving if we act on occupants' behavior? So to do this, we started through a base case where we observed how occupants interact with the building concerning the use of heating, cooling, lighting, and devices. And also through collecting some data from the building. This helped us introduce this information in the simulation tool and see what's the base case consumption of the building. After that, we introduced some interventions that represent a behavior change in the building. And there are 3 levels of this intervention. And as a result to adopting such behaviors, we can see that we have any significant energy saving in the different systems of the building. So if we apply the 3 interventions in the building and we have the three levels of occupants behavior change. We can reach up to 50% of reduction for heating, 7% for cooling. And in the case of cooling, I think that this amount, which is not high as for heating, is due to the fact that the situation of the building is a little bit particular, and its situation helps means that even if we change some behaviors in order to reduce cooling consumption, it is so important that this kind of change can bring a lot of energy savings. A total energy reduction of 28% is possible through behavior change in this building. However, as we can imagine, we cannot have all people adopting this kind of behaviors and accepting all this change. So we studied the case where only people from the south offices in the south part of the building are having a virtual are having an adequate behavior, and that the other part is not. And it's the same case for the north offices and the south offices. So as a result, we can see that if occupants of south offices are respected all the behaviors of the three interventions, we can reach a total of 10% of reduction. And in the case of north ones, we can reach 8% of reductions. So this shows that just on a level of the situation of the offices in the building can have an impact on reducing energy consumption. And this shows that it is important to target the type of the occupants. We can see that they have an ability to change behavior and use this to optimize and have the energy savings we want to have. Now, how can we reach this kind of information and choose the right solutions to apply to the occupants we have? This will be done through experimentation. So the experimentation starts with a survey which aims to understand more the occupants' behavior in the building. First of all, but by having some information about the occupants, their age, their gender, their position and their role in the office building. And also to understand through a part concerning building and occupants, their interaction with the building and the way they consume energy, their perception of the comfort in the building, and understanding also which behaviors we need to change and which behaviors conduct to unnecessary energy consumptions. It's also important to understand their intentions and the motivations behind a change of behaviors in the building. This survey and these answers will help us draw occupants' profiles for which we can choose the right solutions to apply. In parallel to the survey, we have a data collection concerning the use of the building. So like the door opening, the window opening, the temperature set point in the building, the occupancy, and the energy consumption. This data collection is really important in order to know what happened before we integrate a nudge solution and what happened next. And through this data collection, we can also develop the models we integrate in the thermodynamic simulation in order to have annual results about the energy consumption and to be able later to not use experimentation and base our work only on simulation in order to quantify the impact of nudges on reducing energy consumption. Now I will talk about the nudge solution. It is a solution which is low cost, and this is important. As we said, the innovation works are really important, but what is interesting is also to be able to educate occupants and to have, through a low cost solution, important energy savings in buildings. Nudges are based on cognitive biases and doesn't use any financial incentives or any orders. So individual choose to make the decisions we want them to make in order to have less energy consumption. And it is important that a nudge doesn't affect the choices of the occupants. And this is important in the definition of energy efficiency, because in energy efficiency, we need to maintain the comfort of occupants and there mustn't be any restrictions on the occupants. So the nudge is the right solution to have energy savings, but at the same time, give this freedom to occupants. So in our study, we focus on 4 types of nudges. Each type of nudges is adequate to an occupant profile. So the first one is the peer-to-peer comparison, which is based on comparing occupants' consumption to their colleagues, and to benchmark the eco-friendly behaviors other occupants do in order to encourage the occupants to have the same behavior. This is also the occupant is also helped through suggestions in order to reduce its energy consumptions. This peer-to-peer comparison responds to the need of some occupants with high level of competition. The second nudge is the feedback, and this one responds to the need of some profiles to being encouraged to see an improvement in their behavior. And it is based on giving feedback to occupants about their energy use and tailored messages that will encourage them and give them the right behaviors to adopt in order to improve themselves more. The moral appeal talks to occupants that are environmental that have some environmental sensibility, if you can say that, and it is through messages that express the consequences of using unnecessary energy on the global warming and the situation of the planet. The moral appeal is based on pictures that can have an impact on this kind of occupants. And the fourth one is the social review, which talks to or responds to the needs of occupants to see that to be part of a group and to reach the level and the behavior the most of people adopt. So it is based on defining the right behaviors the majority of occupants are using. So these nudges are applied to different offices depending on the responses of the survey and the different profiles we obtained from the survey. And through the experimentation, the nudge is adapted to the evolution of the energy consumption and maybe also to the way, because there is a part in the survey that asks which kind of information you want to have through images or messages or emails or if the occupant is really interested by writing messages or images or pictures. We are conducting the experimentation. We actually, because due to the COVID situation, people weren't in the study of the building in the moment of the experimentation, so there was a delay about that. But I will be happy to share this the results at the end of this experimentation if you are interested. As conclusion to this presentation, we could see that it is important to add some changing of occupants' behavior in order to reduce energy consumption in tertiary buildings, especially that, as I said, the occupants are not paying the bills, and we can do this as an improvement to renovation works, and also the impacts of some change in the behavior and also the situation of occupants in the building and their interaction with the building. So the office location was a proof that just the targeting the adequate occupants and giving them the right indications to adapt, to have the right behavior, can give interesting energy savings. It is also important to identify the occupants' profile for more energy reductions. As per perspective, we want to work also on the improvement of models of behaviors that are that may be integrated in the simulation in order, as I said, to not be obliged to use the experimentation, and also to be able to automate the nudge and to be able to give the right nudge through an automated system. Thank you for your attention, and if you have questions, I'm happy to answer them.
Thank you, Rabab. Thank you very much for this qualitative study. So very different from the two others, and it is quite logical for me, since you studied it on one single building. Okay, so is there any question, please? Ivana, I give you the floor.
Yes, I have a question, but first of all, Rabab, thank you for an excellent presentation. It was really a joy. It was really a joy to watch. So I have one question and maybe one suggestion, if you would allow. So for my question, it would be, I noticed that amongst the nudges, you used peer-to-peer comparisons. Now, if I understand properly, this is an office building. So how could you tell in that type of setting how much each person is consuming? This is what was kind of that I was wondering about, but perhaps I understood something wrongly. And second, a colleague from my university did a research that was related to nudging tourists to behave in a more environmentally friendly way through the use of this moral appeal with different types of like stickers that they designed and placed in separate places. So if you would allow, I would like to link that article to you. Maybe it would be useful to you if you're not already considering it. So yeah, that's it for my side.
Thank you, Ivana. Where do you come from, Ivana? Can you introduce yourself?
I'm from the university, I'm from the School of Economics and Business, University of Ljubljana, and my colleague is Ljubica Knežević-Cvelbar, and she's very active in these field experiments, however, in the area of tourism, but it's also related to energy conservation and environmentally friendly behavior. So just an idea, maybe that would be something that would be useful to you in the framework of your research. Yeah.
Okay, Ivana, thank you. Rabab?
Thank you, Ivana, for your help and for this suggestion. Concerning your question, as I said, the aim of the survey was to know which people will be able to respond to the nudge of a peer-to-peer comparison. And by targeting this type of occupants, we have, as I said, smart meters in the offices. These smart meters will help us see the evolution of the energy consumption and also the activities of the occupants in the building, and we send messages to the occupants during all the period of the experimentation. I hope I answered your
yes, you answered it perfectly. Thank you.
Thank you.
Thank you. Any questions, comments? Yes, Stephanie, please go ahead.
Hello, thank you very much for your presentation. To me, it was very interesting indeed as well. It's not really my field of research, but anyhow, I would like to also ask, just as Ivana did now, regarding how you measure the individual saving. So you said you have smart meters. Do you really, does this office building really is equipped with smart meters in each room? I was just wondering, because I know infrastructural, that is quite an effort to facilitate, so for the facility management to introduce all these smart meters, not only at one central point or maybe at 2 or 3 central points, but in each room, as I've talked to the university here where I work.
Yes. As I said, the objective of the survey was also to know which offices are going to be interesting to install smart meters in, and also the building is the office building works on developing smart meters, so they have this kind of equipment.
Okay, that's great. That's great for this kind of study. Thank you for explaining.
Thank you, Stephanie. Other questions, comments to Rabab presentation? Yes, Alessandra, you're welcome.
Thanks for the interesting presentation. I'm also not at all an expert about nudges, but I was curious because from what I understood, the number of people working in the building is not huge. So what is your plan? So how do you plan to measure the effectiveness of the nudges? From basically, this is a question about the methodology. You will just use the smart meters, or will there be any other strategy?
Okay, normally the experimentation was needed to be conducted in different buildings in order to have different types of buildings and so on, different data, in order to have this opportunity to have the right simulation of this impact. Yeah, this is interesting to say. And yeah, what was the second part of the question?
No, I was because I have some colleagues who conduct research using qualitative interviews. So do you plan to use this kind of tools? Because I'm not using them, so I don't know how they work. Yeah. So how do you measure the effectiveness of the nudges?
Yeah, the work works based on surveys before and after using nudges, and there are interesting results about this. But we thought that adding this part of data collection is important to emphasize the impact of the nudge solution. the survey will be before, questions before to know the situation of the building, but also after to see the impacts of the change. And this will be helped with the results and the measures we have, the monitoring of the building.
Thanks.
Okay.
Any questions, please? Any questions? So maybe I can conclude. So we have seen that these are complicated questions, and I remember that not all signals work, that maybe negative information on consumption can sometimes work, that nudges, which are always positive or even funny signal, can work in other cases, and depending on the region, the country, its formulation, the formulation of the signal, etc. So I think that this is really the philosophy of experimental economics to test this. And I think, so thank you very much for all your three presentations, very interesting. And at the end of this session, and thank you very much to the audience and the speakers and people for the technical aspects. Thank you and bye-bye.
Thank you.
Thank you.
Thank you.
Bye.
It was a pleasure.
Bye.
Pascal, thank you very much for being the chair of this session. If that's okay for everyone, we'll stop the recording.
Thank you.
Thank you, Felix.
so
Thank you very much for supporting us. Bye-bye. Bye-bye.
Welcome.
Bye-bye.
Have a great day, everyone. See you.